be discussing Fourier augmented NARDL model. So the specification of Fourier NARDL model is the same as that of NARDL model, except we have the addition or inclusion of Fourier terms. Okay, we have the inclusion of the Fourier terms. You can see the last terms here before the error term is called Fourier terms. So once this is included in NARDL model, so that NARDL model becomes Fourier NARDL model. Okay, because we are going to use augmented bond test too. That's why we call it Fourier augmented NARDL model. Okay, now this is Fourier terms. As I said, it captures unknown smooth structural breaks in the stability component of the series. So these are the parameter definitions and the variables definitions. You can see them. We have unrestricted. Okay, I won't waste time on this because it's the same specification as ordinary NARDL model. Okay, so we have this, except we include Fourier terms there. So we have the same test, augmented bond test. We are going to carry out the same test as we did under NARDL model, the Fourier. Okay, also this is error correction term. The only difference is that we include Fourier terms. Okay, this definition of error correction term and speed of adjustments, they are as we defined them before. So we have long-run relationship. Okay, it's the same NARDL model anyway. So we have asymmetric test, which is also the same. Okay, which is also the same. So let me go to STATA. Oh, yes, I'm in STATA now. Okay, now let me open the do file we are going to use. The do file we are going to use is Fourier NARDL model. This is it. Then I open the do file. Okay, I open the do file. So I told you wherever you want to carry out any analysis, okay, so don't forget the first thing to set to working that I've done that, okay, to the right folder. Then now I'm going to declare my exact time series, okay, declare exact time series. So I've done that before, okay. Then generate the log series for exchange rate and GDP. Then moving to the Fourier augmented NARDL model. Okay, here we have this. Estimate NARDL model. We want to estimate NARDL model. It's very simple. We use the command we have been using, then the dependent variable, the target variable, then we have the control variables. You can see this is the type of the model, then the decomposed variable. This is the arithmetic variable. Then we have the maximum line, we set it to the default. Then we have the maximum frequency we want. So we set it to 3. Because actually you can see a variable that will have more than 3 frequencies. Okay, so we have default, we use default 2. So we have case 3 as usual. So let me run this. Okay, like I said, always check your diagnostic test first. Okay, you can see here we have normal difference, but there is serial correlation. There is homoscedasticity correlation, but we have problem with serial correlation. It means that our bond test result will not be valid. So we may need to reduce the lag or increase the lag. Okay, to see. So you may need to increase the number of lag, until you are able to achieve that. Increase, reduce, increase until you are able to achieve that. Okay. So in order not to waste our time, so we are going to ask, because the content result is not valid because of this. So until you are able to resolve this issue, okay. So serial bond test is not valid. So I'm just assuming that it's valid. That is, there's no serial correlation. So you can see based on this, all these tests are significant. It means there's long-run relationship. So you can go and interpret, mind you ensure there's no serial correlation before you do this. So I'm only assuming no serial correlation. So it's significant. You can see we have the speed of adjustment, that is 0.868%. It means if the deviation, that is if the deviation in real GDP in previous year. So about 68% of the deviation will be corrected in the current year. So that's what it means. So here, positive changes in exchange rate does not have impact on real GDP in the long run, while negative changes have. Okay, you can also have, see this one. This one negative. This one has negative impact. That inflation has negative impact on GDP in the long run. Trade openness does not have a significant impact. Also moving to the short run. Moving to the short run. So you interpret, you check the domain as significant. You can see all these are significant. It means the positive changes have negative impact on real GDP. That positive changes in exchange have negative impact on real GDP in the short run. Okay, for these negative changes, okay, we have two that are significant, this, and they are positive. Okay, it means that negative changes in exchange rate have positive impact on real GDP in the short run, and we also have inflation. Initially, inflation has negative impact on real GDP in the short run, but later, this negative impact turns to positive impact later in the short run. Okay, and for trade openness, we have this one that's significant. That's what we are going to interpret. So it indicates that trade openness has negative impact on real GDP in the short run. Okay, so let's also see this Fourier terms. You can see these Fourier terms. So let's go and check the overall test, John test for Fourier terms. John test for Fourier terms. Okay, you can see this is significant. It means that Fourier terms, okay, are justly significant. So we need Fourier terms in our model. Okay, so if this is not significant, okay, there's no point in using Fourier. There's no point in including Fourier in our specification. Okay, it means that we'll have used ordinary NARDL model without Fourier. Okay, but it is significant. It means Fourier terms is necessary in our specification. That is what it means. So you may also want to take a look at the graph to see this is the graph. Okay, so this is the half where the half of the effect is cut off. So you may want to see it clearly. Look at the figure here. Okay, look at the figure here. Okay, about 7 months. Okay, the half of the effect of the shock on real GDP will disappear within 7 months. Okay, within 7 months. If there is a shock to real GDP, that's what it means. Hope you understand that. So see you in the next class.